this is the sine graph that we're all used to seeing. Agreed? Agreed. Okay, so when we do inverse functions, what happens to our x and our y axes? They switch. So technically, well, this is going to be improper, but technically the graph rotates like that, right? To where the 1 and the negative 1 are now on our x-axis. And the radians, the negative pi over 2, the pi, and so on, are on our y-axis, right? Okay, let me turn this back, though, because we want it the right way. So let's go ahead and plot our inverse function by doing that. And we're going to plot a few points and kind of see how this inverse graph is going to turn out. Okay? So let's go to the next page. Let's get our chart. I'm going to do a t-chart. Okay? And we're doing the inverse of sine. So remember that key on your calculator that I told you guys not to use? Remember? And you guys said, that's the reciprocal function. And I was like, no, it isn't. That's the inverse key. The one with the negative ones, okay? And then we have our output. Okay. So now, when sine is 0, right there, our output is 0, right? So we need to switch those. So our output was 0, and our endpoint was 0 radians. That's an easy one, okay? All right, well, let's go ahead and do the positives. We're used to that. So at pi over 2, what is sine? What is sine? 1. Okay, so we need to put our output here. So 1 and pi over 2 here. Okay? All right, what about a pi? What is it? 0. So we put our input here and our output here. Okay, what about 3 pi over 2? Negative 1. Okay, what about a 2 pi? 0. Okay, so I'm going to do the same for the negatives because we're kind of out of room. So we have the same chart going. All right, what is it at negative pi over 2? Negative 1. You guys see how we're just looking at the y values? Okay. So we put negative 1 here, negative pi over 2 here. Okay, what about negative pi? 0. Okay, and what about negative 3 pi over 2? 1. Okay, and what about at negative 2 pi? 0. All right, before we even get to the graph, what do you notice about the chart?
It has repeating y values.
Okay, it has repeating values. Now, have you guys ever seen a graph that has multiple outputs with our inputs?
No.
It's not what? It's not a function.
No.
Oh.
Loop over each other.
Okay, so remember when I took this graph and I flipped it? Right? If I flip this graph again, and we know that this graph is going to look squiggly if I plot these points, is my vertical line going to pass? Is that vertical line test going to pass? No. Okay, so we're going to have to restrict our original sine graph. All right, well, let's go back to the unit circle to do that. All right, so here's the unit circle. We all seen it? We all know it? Sine relates to what values, x's or y's? The y's. Okay, sine is related to the y values. Okay, so my y values are positive here, then they're negative in the other two, right? So aren't the y values in quadrant 1 exactly the same as the y values in quadrant 2? So we only need one of those quadrants. Aren't the y values in quadrant 4 the same as the y values in quadrant 3? So we only need one of those. So it turns out that when we look at the unit circle, at the domain of sine, we only need a section of that graph. All right, so here I restricted it to just quadrant 1 and quadrant 4. And this is because now I have my positive y values there and my negative y values there. So I have all the y values that are possible in the unit circle. Agree? Okay, so we're going from pi over 2. And if we go backwards, that's the same as saying it's negative pi over 2. Okay, so I'm only looking... Yeah, negative pi over 2, we go backwards. That's something I talked, I think, about briefly, but we haven't really dealt with too much. So if we go back to our chart, it means that we're only looking at the values from pi over 2 all the way to the negative pi over 2. So we only care about those 3 key points. All right, so what does this graph look like, my slice? Oh, I have a picture for that too. All right, give it a second. Here it goes. So notice here, I have the same sine graph, but what did I do? What did I do in the middle? I made a different color, right? Yes. I restricted it. In fact, this point right here is half between 0 and pi, right? So that's my pi over 2. And this point right here, that's my negative pi over 2. 2. You can do it. There it is. All right, so if you notice it here, I've restricted it from the negative pi over 2 to the pi over 2. Agreed? So now if I only look at those points, the graph actually turns out really nice. In fact, I think I can do grid paper here. Give it a second, though. It's delaying. It's the Wi-Fi. It always does this. All right. How's this working again? So here we go. Let's go ahead and plot our points. So we have a nice straight line here. Okay. We have our 0 point somewhere around here. Oh, wow. That was not on there.
Why don't you get a stylus at Walgreens?
Because that costs money.
They're like $2. Steal it.
I'm just too lazy to... Thanks. I got that recorded, by the way. All right, so here we go. We know we have negative 1 here.
Wait, so you can hear everything we're saying?
Yeah. Positive 1 here.
I love you, Mom.
Okay, we have positive pi over 2 up there. And then we have negative pi over 2 here. Okay? So if you remember, at 0, that's what sine is. Right? Sine is 0 at 0. At negative 1, sine was negative pi over 2. Right? And then at positive 1, it was a positive pi over 2. Okay, now I know it looks like a straight line, but it's curved. Kind of goes like this and then goes like that. Okay? So the graph looks like. Alright, why did I spend so long on this graph? Well, this is why. Because we're going to get into finding values of sine. So if I ask you, what is sine of negative 1 of 5? What are you guys going to tell me? Well, you guys, look at this graph. Where is 5 on this graph?
Where's 5? To the right. 5 is on the right.
Okay, so 5 is somewhere way over here, right? We don't know where. Is that on the graph?
No.
So we don't know what sine of 5 is. It's impossible. In fact, if you put that in your calculator, it'll probably say domain error. And the reason why is because you have to go back to this graph, okay? This graph is telling you that you restricted the domain between negative pi over 2 and pi over 2. So you're only going to get output values that are in that the first and fourth quadrant. Okay? I know, it was a little delay there, okay? And you should only get an input value that's either greater than negative 1 or less than a positive 1. So it should be between these two values. Okay? Easy enough? All right, how do we put this in the calculator? This is the easy part. All right, so on your calculator, we're going to find out what sine the inverse of sine of 1/2 is? There's two ways to do this. One, you just punch it in the calculator. By the way, make sure your mode is in degrees. Makes it easier. Unless the directions tell you otherwise. Okay? Or, just go to your unit circle and look at it. Alright, so here's the unit circle. Where is our y value 1/2 in the first quadrant? At 30 degrees. Now I know that it wasn't going to be in the fourth quadrant because my y values are negative, okay? And you have to remember that this was originally our output, right? So I'm looking at these values and I'm getting an answer that's a degree or a radian. Degree or a radian. Oh, that was really sloppy. You guys can get over it, okay? But you guys understand that? We're working backwards, okay? So you guys can just look at the unit circle and go, oh, it's 30 degrees. I'm done. Okay? Or punch in your calculator. Hit second sine of 1/2 or 0.5, and it will give you 30 degrees. It's that easy. We're getting there. All right. Notation. Sine of x, you guys, is the same thing as arc sine of x. They came up with this notation because people were getting confused with the -1. They're like, oh, I'm just taking sine and raising it to the -1 power. No, you're not. Okay? So if you see somebody write arc sine, or if I say arc sine, it means the same thing. Different notation. It's like DMS and degrees. They're the same thing, but different notations, right? So don't get freaked out about that. Okay. What is cosine of sine of root 3 over 2? Where do we always start when we have problems? In the parentheses, 10 dash, right? So we're looking at this part first. So where is sine equal to root 3 over 2? Well, think about it. We just did sine of 1/2, right? Which was 30 degrees. So this one must be 60. All right, so now that means this entire part is going to become 60 degrees. Well, what's cosine of 60 degrees? 1/2. That's my answer. I'm done. Two-part problem. I have you work backwards and then go forwards. You guys get it? Okay, one more. What is sine of tan, the inverse of tan of 1? I didn't talk about inverse of tan or inverse of cosine yet, have I? But they work the same way. Well, when tangent is 1 at one of the 45 degrees, right? Agreed? Okay, so we're looking at sine of 45 degrees, which is? You guys should know that one. Nah, give me exact value. 45 degree ones, they are exactly the same for sine and cosine. Root 2 over 2. Okay? Alright, real fast. Let me talk about the restrictions of cosine. Alright, cosine. Here is a domain restriction for cosine. So notice for the inverse of cosine, we go from 0 to pi. Because in the first quadrant, I have my positive x values. And in the second quadrant, I have my negative x values. Have I covered all my bases? Yeah, I have. Okay? The arc cosine looks very similar to the inverse of sine. I'm not worried about the graph. Just know that you're in the first and second quadrant for cosine. So your calculator is only going to give you answers in the first and second quadrant. Easy enough? Okay. All right, one technical question because this was bugging me today. What is negative 30 degrees? What is that? Like, where is that on the unit circle?
It would be about 3 330.
Right here.
We have 330 degrees. Okay?
236, you can go down.
Yeah, this is why. Okay, so negative 30 degrees means we go backwards. Proper grammar there. 30 degrees, right? And that's why it's the same as 330 degrees. Understand? Okay, so if you get negative values, your answer isn't wrong. Just find the coterminal angle.
Okay.
Oh, coterminal again. Oh, no, Miss Sykes. Yeah. Okay. Just add 360 to it. If that's easier, I'll accept both answers. Long division. All right, any questions over this? Are we good? All right, what we're going to work on. We are on page 421. I haven't decided yet. Numbers 1 through 20 all. And numbers 23 through 32 all. And I need to figure out where the page is. So we're on page 432, number 10. I only gave you one problem on that page. Okay?